Okay, so we were going through the formulas, and now we're actually going to start the assignment. So hopefully you guys are looking at worksheet 3-4. Not too many problems on it. We're only going to go numbers 9 through 30, so that's only 22 questions. I'm going to do 11 of them with you guys, and then 11 of them you guys can do on your own. So we're going to do the odds together like usual. So we have question number 9. We have the sine of 5 pi over 12. Now, most of you guys don't like radians so much, so I have no problem if you want to change those to degrees. So remember how to change the degrees. We times by 180 over pi. That way the pi's will cancel. 12 goes into 180 15 times. 5 times 15 is 75 degrees. Now we're not done. I want to know what is the sine of 75 degrees, okay? So what formula are we going to use, okay? It's obviously got to be one of 3 or 4 because I want the sine, okay? And we could use either one, it doesn't matter. Generally, students tend to like to use the sum ones and not the difference ones, just because adding is easier than subtracting, okay? So I'm going to use equation number 3 here, sine of alpha plus beta. So what we need to do is, we're going to use our unit circles, unless you have it totally memorized in your head, you can just, really good in your head, you can do that, otherwise just a unit circle. Look at, for 2 angles on the unit circle that add up to 75, okay? Or you could subtract off to get 75. It doesn't matter, okay? But since we're going to use equation 3, I'm going to use the sine of 45 degrees plus 30 degrees, because you see both of those on there. I mean, could I have made it 60 plus 15? I could. 60's on there, but 15's not. So that's no good, okay? So we use this formula. We take the sine of the first angle times the cosine of the second angle. So it's the sine of the first angle, 45, times the cosine of the second angle, 30. Then we have what? Plus the cosine of the first angle, cosine of 45, times the sine of the second angle, which is 30, okay? Then we look at our unit circle. The sine of 45 degrees is radical 2 over 2. Cosine of 30 degrees is radical 3 over 2. Cosine of 45 degrees is radical 2 over 2. Sine of 30 degrees is a half, okay? I think I actually did this one at the end of the video. Looks real familiar here. Radical 2 times radical 3 is radical 6 over 2 times 2. Don't forget to times those. 2 times 2, which is 4. Plus 1 times radical 2 is radical 2 over 2 times 2 is 4. So I could just say the radical 6 plus radical 2 over 4. That's the exact value of the sine of 75 degrees, okay, or the sine of 5 pi over 12, okay, same thing. So that's what you do. You just basically did all that work to come up with these formulas. Now it's just, here's some formulas, plug in the stuff. That's all you do, okay? So how about the cosine of 7 pi over 12? Number 11, cosine of 7 pi over 12. So again, I'm going to make them degrees for you, 180 over pi. Pi's cancel, 12 goes in there 15 times. 7 times 15 is 105 degrees. Cosine of 105 degrees, okay? This time we're going to use one of these two. And again, you could either find 2 angles on the unit circle that add up to 105, or 2 angles that subtract off to get 105. I'm going to do the first one. That's the same as the cosine of 60 degrees plus 45 degrees, okay? So I'm going to use equation number 1 because it's cosine and we're adding. So the cosine of the first angle times the cosine of the second angle. So the cosine of 60 times the cosine of 45 minus the sine of the first angle times the sine of the second angle. And then we look at our unit circle. The cosine of 60 degrees is a half. Cosine of 45 degrees is radical 2 over 2. Sine of 60 degrees is radical 3 over 2. Sine of 45 degrees is radical 2 over 2. We're just getting these off the unit circle, okay? 1 times radical 2 is radical 2 over 4. Radical 3 times radical 2 is radical 6 over 4, so the answer is radical 2 minus radical 6 over 4. I told you, the actual problems themselves are really easy. You just, here's a formula, plug them in, okay? Let's look at number 13. Question number 13. Cosine of 165 degrees. Okay, so the cosine of 165, again, we're going to use either equation 1 or equation 2, okay? I'm going to use 1 again. I like the addition ones better than subtraction. It's easier to add than subtract. I mean, subtraction's not hard, but adding's easier. So, 2 angles that add up, that are on the unit circle, that add up to 165. I'm going to use the cosine of 120 degrees plus 45 degrees, okay? I mean, you could have done 30 plus 135. You could do that, okay? They're both on there. There's not a right way of doing these, okay? So there's more than one way you can do them. So we're going to use the sum. And again, these are called sum and difference formulas. Because we're adding, subtracting for sines and cosines and tangents, okay? Sum and difference formulas. So I'm going to use equation number 1. We take the cosine of the first angle, 120 degrees. Now, if you're wondering how do you know which one's supposed to be first, it doesn't matter. It doesn't matter. Addition is commutative. times the cosine of 45 degrees minus the sine of 120, the first angle, times the sine of 45 degrees. Okay? Then we look at our unit circle. The cosine of 120 degrees is what? Negative half. Times the cosine of 45 is radical 2 over 2. Minus the sine of 120 degrees is radical 3 over 2. Times the sine of 45 degrees is radical 2 over 2. And this is over 4 and over, it's going to be all over 4. Okay? So negative 1 times radical 2 is negative radical 2. Radical 3 times radical 2 is radical 6, so negative radical 6. Negative 2 minus radical 6 over 4. Okay? Hopefully you're finding these aren't too bad. I'm kind of zipping through them kind of quick, so I mean that's the benefit of being on video. You guys can stop it, pause it, back it up, stuff like that. But I mean all we're doing is here's some formulas, pick one, plug in the stuff. 15, tangent of 15. I will tell you this, you're not going to like the tangents as well. Okay? You're not going to like the tangents. So in this case, you might be thinking, how do you add up to get 15? You can't necessarily, unless you use negative angles. Well, we can subtract off. I'm going to say that's the same as the tangent of 45 degrees minus 30 degrees. 45 minus 30 is 15. So I'm going to use equation number 6. It's got a tangent, and we're subtracting. So you have the tangent of the first angle, tangent of 45, minus the tangent of the second angle, 30, over 1 plus the tangent of the first angle, which is 45, times the tangent of the second angle, which is 30. Okay? Tangent of 45 is 1 minus the tangent of 30 degrees is radical 3 over 3 over 1 plus the tangent of 45 degrees, which is 1 times the tangent of the second angle, radical 3 over 3. Okay, we're going to clean this up a little bit here. Okay? So we have 1 minus radical 3 over 3. If I times by 1, I'm just going to erase that. That's gone. Now, this is unacceptable because we have radicals in the denominator. We can't have that, okay? Here's what I'm going to do. First off, I'm going to get common denominators everywhere, okay? I have denominators of 3, and then make those 1 over 1. Common denominator is 3, okay? To make a 1 into a 3, we times 3, so times that by 3. So we have 3 over 3 minus radical 3 over 3, and 3 over 3 plus radical 3 over 3. And since we have fractions all over the place and the denominators are all the same, we can cross them all off. So we have 3 minus radical 3 over 3 plus radical 3. Okay, that's better, but we're still not there. We can't have radicals in the denominator. Okay, so we've got to times the top and the bottom by the conjugate of the bottom. The conjugate of 3 plus radical 3 is 3 minus radical 3. So if we times the tops, FOIL it out, 3 times 3 is 9. My outers, 3 times negative radical 3 is negative 3 radical 3. My inners is also a negative 3 radical 3. My last, negative radical 3 times negative radical 3, and negative times negative is a positive. Radical 3 times radical 3 is radical 9, which is 3. Over. And if you remember when you times conjugates, just after your first and your last, your outers and your inners will cancel. Okay, so we do our first, 9. My last, positive times negative is a negative. Radical 3 times radical 3 is radical 9, which is 3. And we can clean this up. 9 and 3 is 12. Negative 3 radical 3 and negative 3 radical 3 is negative 6 radical 3. 9 minus 3 is 6. Divide each of these by 6. You're left with 12 over 2, which is 12 over 6, which is 2. Minus 6 over 6 is 1. So the answer is 2 minus radical 3. And again, what we're finding is that is the exact value of the tangent of 15 degrees. 2, take away radical 3. Okay? Let's look at number 17. Only 2 more of these longer ones, and then we're going to do some shorter ones, and then we'll be done. Okay, 17. So we have the sine of 17 pi over 12. Okay, I want to make those into degrees to make it a little bit easier for you. Times by 180 over pi. Pi's cancel. 12 goes into 180 15 times. 17 times 15, I'm not sure what that is. 85, 255. So the sine of 255 degrees. Okay, so it's going to be one of these two. And you can either find 2 angles on the unit circle that subtract off to 255 or add up to 255. I'm going to do the sine of 210 plus 45. Okay, there's more than one way. You could have done 135 plus 90, I think. Yeah, you could have done, no, not 90. 135 and 120. You could have done that. Okay, so there's more than one right way of doing it. So since we're adding and it's a sine, it's going to be the sine of the first angle, sine of 210 times the cosine of the second angle, plus the cosine of the first angle, cosine of 210, times the sine of the second angle, which is 45 degrees. And then we just look at our unit circle, okay? Sine of 210 degrees is, what, negative half, times the cosine of 45 degrees is radical 2 over 2, plus the cosine of 210 degrees is negative radical 3 over 2, and the sine of 45 degrees is radical 2 over 2. Again, we're timesing, we're going to have 4's on bottom. Negative 1 times radical 2 is negative radical 2. Negative radical 3 times radical 2 is negative radical 6. So negative radical 2 minus radical 6 over 4. Okay? All right. One more of these longer questions. Not that these are that long. Then we're going to do, I don't get it because I tell you what, every year this happens. I think of this worksheet, the problems we're doing right now are the harder questions. The ones we do at the end, I think are easier, but for some reason the students tend to think that they're tougher, okay? Well, we'll see what you guys think. Let's look at number 19. Okay, what about secant, okay? Secant of negative pi over 12, okay? First off, let's make it into degrees to make it easier for you. So times by 180 over pi. Pi's cancel, 12 goes in there 15 times. So it's a secant of negative 15 degrees. Negative 15 degrees, okay? So which formula do you think we're going to use? Well, hopefully you know that we're going to use one of the cosine ones, okay? Because cosine and secant are reciprocals of each other, okay? So what we're going to do is we're going to use the cosine ones, but then we're going to flip our answer at the end. Okay, at the very end we're going to flip it. Now, could I just say that's the same as the secant of 15 degrees? The answer is yes. If you remember, cosine and secant are even functions. We could just do that. Secant of 15 degrees. So, find two angles on the unit circle that add up or subtract off to 15. I'm going to say, I'm going to change these to cosine for right now. Okay, but remember, I'm going to write the word flip. We've got to flip these, okay? So, secant, let's say it's the same as cosine of, let's do 45 degrees minus 30 degrees, okay? So cosine of subtraction, we're going to use equation number 2. So cosine of the first angle, cosine of 45 degrees, times the cosine of the second angle, 30 degrees, plus the sine of the first angle, 45 degrees, times the sine of the second angle, which is 30 degrees, okay? We look at our unit circle, cosine of 45 is radical 2 over 2. Cosine of 30 degrees is radical 3 over 2. Sine of 45 degrees is radical 2 over 2. Sine of 30 degrees is a half. Again, we're going to have 4's all over the place, okay? Radical 2 times radical 3 is radical 6. Radical 2 times radical 1 is radical 2. Now that's if it was cosine, but I want secant, so I need to flip it. So instead of having radical 6 plus radical 2 over 4, we're going to have 4 over radical 6 plus radical 2. Are we done? Nope, you can't have radicals in the denominator, okay? So we times by the conjugate at the bottom, times by radical 6 minus radical 2. 4 times radical 6 is 4 radical 6. 4 times radical 2 is 4 radical 2. Just do your first and your last. Radical 6 times radical 6 is radical 36, which is 6. Minus radical 2 times radical 2 is radical 4, which is 2. So we have 4 radical 6 minus 4 radical 2 over 6 minus 2, which is 4. Divided each by 4. So you just get radical 6 minus radical 2. Okay? All right. Now, when we get to 21, these last 5 questions, okay, what you need to understand, well, let me say this. Jot this down quick so I'm erasing it, or pause the video. I don't want to just tell you this. Hopefully you can see it. When you look at like question number 21, okay, you might be going, how the heck are we supposed to find the sine of 20 degrees and the cosine of 10 degrees? Short answer is, I don't know what they are, and I don't really care what they are, okay? We don't need to know. I don't want to know what the sine of 20 is, and I don't want to know what the cosine of 10 is, but I want to know whatever the sine of 20 minus times the cosine of 10 plus the cosine of 20 times the sine of 10. So I want the whole answer, okay? The individual parts, I don't know, and I don't really want to know. I don't really care. I just want to know what the final answer is, okay? Cosine of 20 degrees, sine of 10 degrees, okay? So what we're doing is we're working backwards, okay? Instead of looking at these and plugging in there, we're going to look there and plug in over here, okay? So when I look at these, okay, does this look like equation 1, 2, 3, 4, 5, or 6 over here, okay? It definitely doesn't look like the tangent ones because there's no tangents anywhere and there's no fractions anywhere. So which of these 4 does it look like? Does it look like one of these up here? No, These have your cosines together and your sines together. Cosines are together, sines are together. Here, your sines and your cosines are mixed. Sine and cosine, cosine, sine. It's got to be one of these two. Is it like 3 or 4? Well, because the plus sign, it's got to be equation 3. So what we're saying here is we're going to use this formula, but we're going to plug them in over here. So A and B are my two angles. So it's just saying add your two angles. It's the sine of adding the two angles. The sine of adding the two angles. 20 plus 10. So the sine of 30 degrees. How do you find the sine of 30 degrees? You better not say, I don't know. We've been doing that since the second day of school, okay? You look at your unit circle. The sine of 30 degrees is a half. Done. 23. We have cosine 70, cosine 20. And what? Minus sine 70, sine 20. Okay. So which formula does it look like? We have cosines together and sines together in subtraction. Well, it's going to be this one. Cosines are together, sines together, subtraction. This says the cosine of, add up the two angles. So the cosine of, add them up, 70 plus 20. So the cosine of 70 plus 20 is 90. You shouldn't look at unit circle on this one. The cosine of 90 degrees, cosine of 90 is 0. Okay, cosine of 90 is 0. At 90 degrees, that's the x value for cosine. Okay, 25. Tangent 20, I'm not going to write this one down. Tangent, it's tangents all over the place, and it's plus on top, minus on bottom. It's plus on top, it's minus on bottom, so it's tangent of, add the angles up. It's a tangent of, what are the two angles? 20 plus 25. So it's a tangent of 45 degrees. Tangent of 45 degrees is 1. Look at our unit circles, we see it's 1. Okay. We could convert these to radians if I really wanted to. I don't think we need to on this one though, okay? We just look at them. It's sines mixed with cosines, and it's subtraction. So it's got to be sines mixed with cosines, but it's got to be subtraction, so it's got to be this one. It's the sine of the first angle minus the second angle. The sine of the first angle, which is pi over 12, minus the second angle, which is 7 pi over 12. Okay? That's the same as the sine of 1 minus 7 is negative 6 pi over 12. 6/12 is the same as 1/2. So the sine of negative pi over 2. Well, positive pi over 2, right there, the sine is 1, so negative pi over 2 is negative 1. And 29, last one. Okay, we have cosines together and sines together, and it's plus in between them, so it's got to be this one. Cosines are together, sines together, plus in between. Again, we're just, instead of going from here to there, we're going from there to here. So we're going to do this one. This says the cosine of the first angle minus the second angle. So the cosine of the first angle is pi over 12, minus the second angle, which is 5 pi over 12. Okay? Well, 1 pi over 12 minus 5 pi over 12 is negative 4 pi's over 12, and negative 4/12 is the same as negative 1/3. And can I just say the cosine of positive pi over 3? Sure, because cosine's an even function. And we look at pi over 3, the cosine is a half. Okay? All right, that's it. So anyhow, this assignment is due on Tuesday. We'll have a homework quiz on Tuesday, the 8th, December 8th. Hopefully this isn't too bad, easier than the last one. So, all right, if you have questions, email me and get back to me, all right? See you guys later.